Hi friends. So after taking the examples on Laplace transform of integral, let us move ahead with one more example on Laplace transform of integral. Now guys, here in this example we are going to see how to apply two or three properties together and how to evaluate the question using those properties. So here we have to find out Laplace of hyperbolic cos t integration 0 to t e to the power u hyperbolic cos u du. Now guys, here the integration is from 0 to t. It clearly shows that we have to use Laplace transform of integral property. But with this integral, we also have one more term extra, that is hyperbolic cos t. So if we want to apply Laplace transform of integral, then we should not have any term outside that integration. So all terms or the function of u is generally inside the integration. So what to do with that? So guys, don't worry. This hyperbolic cos t, we are going to use it after applying Laplace transform of integral. So how to use it? So we are going to convert that hyperbolic cos t into exponential function by using Euler's formula. So here I'll show you that Laplace of hyperbolic cos t integral 0 to t e raised to u hyperbolic cos u du is nothing but Laplace of, so this hyperbolic cos t is e to the power t plus e to the power minus t upon 2 into integral 0 to t e to the power u hyperbolic cos u du. Now guys, 1 by 2 is a constant, I'll take it outside, and we will multiply this integral with e raised to t and then e raised to minus t. So it will give us Laplace of e raised to t integral 0 to t e raised to u hyperbolic cos u du plus Laplace of e raised to minus t into integral 0 to t e raised to u hyperbolic cos u du. Now guys, if you see these two terms, then along with this integral term we have e raised to at term. So if you see from left hand side, then it looks like e raised to at into f of t. So it means it is first shifting property. So guys, we are going to solve this by first shifting property. So here also as well as here. So in both the cases, e raised to at f of t. So this integral is nothing but our f of t. So here I'll say, here f of t is equal to integral 0 to t e raised to u hyperbolic cos u du. And the Laplace of this is phi of s, which we are going to use to evaluate this. So here I'll say, using first shifting theorem, this term will be half in bracket, by first shifting theorem we will get phi of s minus 1 and here plus phi of s plus 1. And guys, for finding these two values, we have to first get phi of s, and we will get that phi of s from Laplace of f of t. So for time being, I will call this as equation number 1. And now we'll move to find out phi of s, and we will put that value of phi of s to get the value of phi of s minus 1 and phi of s plus 1. So let's start. So here I'll take this function, I'll find Laplace of this. So therefore Laplace of f of t is nothing but Laplace of integral 0 to t e raised to u hyperbolic cos u du. Now guys, this is exactly matching with Laplace transform of integral property. So in that the answer is given by 1 upon s into function of s, which is nothing but the Laplace of this f of u. So let's find out Laplace of this and then apply the Laplace transform of integral property. So Laplace of e raised to u hyperbolic cos u equal to. So guys, this is again matching with first shifting property. So accordingly, answer of this is phi of s minus 1. So you can call it as phi 1 because it's a different function. We have already called phi in the previous equation. So phi 1 of s minus 1, where the phi 1 of s is equal to Laplace of hyperbolic cos u or hyperbolic cos t, which is nothing but s upon s square minus 1. So guys, from this phi 1 of s, I'll be finding phi 1 of s minus 1. So it is nothing but s minus 1 upon s minus 1 the whole square minus 1. And guys, this is nothing but the Laplace of this function, and I can call it as, let's say, psi of s. So if I want to find out Laplace of this function by using Laplace transform of integral property, then we can say that the answer is 1 by s psi of s. And psi of s is nothing but Laplace transform of this function. So here I'll say using Laplace transform of integral property. So guys, here I got value of psi of s like this. So here I'll put that value. It will be s minus 1 upon s as it is, and this is s square minus 2s plus 1 and again minus 1, so that will be s square minus 2s only. So guys, here I got Laplace of f of t, that is Laplace of this function, and as I said that this f of t we got from here from the first shifting theorem. So guys, the Laplace of this function of t is gonna be my phi of s, which I want to use to find out phi of s minus 1 and phi of s plus 1. So it means the value that we got here, this is nothing but our actual phi of s, which we have to use to find out this phi of s minus 1 and phi of s plus 1. So that will become, so the final answer is Laplace of the hyperbolic cos t integral 0 to t e to the power u hyperbolic cos u du is equal to half in bracket. Now to get phi of s minus 1, I will replace s with s minus 1. So here I have s, I'll replace it with s minus 1. Guys, we can simplify this further like this. So s minus 1 upon s is common. So s square in bracket s minus 2. And in this phi of s, I will replace s with s minus 1. So this will become s minus 1 minus 1, that is s minus 2, upon this will become s minus 2 square. I mean s minus 1 square, because we are replacing s with s minus 1. So s minus 1 square, and this will become s minus 1 minus 2, that is s minus 3, plus, now let's find out the value of phi of s plus 1, and for that we will replace this s in phi of s with s plus 1. So now this will become s plus 1 minus 1, 1 and 1 cancel, so we will get s. Here I'll write down, so I'll write that term here. So s upon, then we have s square, will replace s with s plus 1, so s plus 1 the whole square. Again s plus 1 minus 2 is s minus 1. So guys, here we got the value. In this, if you want, you can take some terms outside which are common, like s minus 1 is common, so it will be 1 upon 2 times s minus 1 outside, and in the bracket we will get s minus 2, here s minus 1 and s minus 3 as it is, and here we will get plus s upon s plus 1 the whole square. And guys, this is nothing but the Laplace transform of given function. So I'm sure that you understood how I've applied Laplace transform of integral property along with first shifting theorem, and how we got the different function of s, and then we got the final function of s for the given function of t. Thank you.